All right, everybody. This is the bonus session for today's, this is the bonus session for day 2, where I will cover a couple of topics that were not included in the original, like in the 3 hours that we had today in the morning. We will cover a couple of things. I show you how to, for example, generate images from a model, right? From pre-trained models. I gave you a couple of models, one trained, for example, on Frank Gehry's data, and also one that generated like faces. It was one of the pre-trained StyleGan2 ADA by NVIDIA. But what I'm going to show you now is like how, for example, can you train with your own images? And that is not a very complicated process, but this bonus video has like 2 goals. Being the first one, teaching you how to get data in an easy way, because you need like a lot of images. And a good way, for example, to start creating data sets is by doing the things that I will teach you. And of course, training and showing you like some tricks about training GANs that will be useful, that hopefully you will use over the weekend. So let's start. I will share my screen. So the first thing that we are going to use is this. This is a big shout out to Jeff Heaton. He has a YouTube channel that's actually very useful for a lot of things, but he has like this a specific code. If you go to github.com, Jeff Heaton, PyImage data, he has this repository that we will use today to actually get stuff. So I will share this. For this, we need to do a couple of things that I will teach you as well. So just let me save this in a safe place. Actually, I'm going to save it in the folder that I'm using for this digital futures. Oh, actually, I already have it. So yeah, you just save it to a folder. And one of the things that you need to do is go install something that is called Visual Studio Code, or VS Code. That is the editor. If you go to code.visualstudio.com, you will download this editor. Basically, it will know what is the operating system that you're using. In this case, we're using Windows. I'm using Windows. In the morning in the class, during the class, I used Mac. So it doesn't matter. If you download this and install it, you will see a window like this. I have something else like open. Actually, let me just close everything that I have here. I have like a bunch of stuff. Close all. Basically, you will see a window like this, like pretty similar to this. And you just want to go open folder, and then you go to summer 2021. In my case, I mean, this is where I have everything. I will just enter here and I will select the folder. And you will see exactly this. And let me arrange everything here. And this is the repository. Basically, I downloaded the files, and this is a repository from Jeff Heaton that will allow you to download a lot of images according to like specific parameters using the Flickr database. So let's check a couple of things. This is something that basically will scale and process images and will do the dirty work of actually collecting data for you. This is one of the ways that you can train a GAN. So for example, you can take images by yourself, but take into account that you need at least like 1,000 images to train something that is kind of meaningful. The more data you have, the better it will train, the more time it will take, but also the better it will train. So here you have the code. You have like a couple of utilities that will process your images, and they will format everything. But one of the most important things is here. So for example, this is a config underscore flickr.ini, INI, sorry, file. And it has like a couple of parameters that the file, the Flickr download Python script will take, and it will use to actually generate or download the images that you want. So you have here something that is called an ID and a secret, right? And also you have a path that you need to specify. So one of the first things that we want to do, because it's easier to do, you just go to like whatever hard drive you like, or like any folder that you have. So for example, here I will create a new folder that it will be like DF for digital futures, right? And this path I will put here. So basically it will be DF, because that is the path. Sorry, in my case it's G. It's the G drive data DF. So I will download everything over there. You can change this, like for example, what do you want to search? We can search, for example, I don't know, like skyline, for example. And the prefix, it could be actually, I mean, it could be something, I don't know, by default is this. Let's say we want to train over, like, again, I show you Frank Gehry, but let's say we want to train over, actually, let's do something. Let's go to flickr.com. And actually, this is quite important, because for this part of the tutorial, you actually need to get a Flickr account. In my case, I have had this Flickr account for a long time, and you know that Flickr is a platform where you can upload your pictures. These are my pictures that I've taken like over the years. So it's a very good repository with it's a large database actually for things like this. So you can search for, I don't know, for example, like if you go here, we can search for Naga King Tower, and actually this is pretty good. If you search here for Naga King Tower that is in Tokyo, you will find a lot of images and interesting images from the Naga King Tower, because it's like super and quite interesting. So for example, let's say you want to train over like Kyoto, for example, you will find like that. Or in my case, I want to find like pictures of Boston, or I can say like Boston, the skyline. So for example, I could play with this. I'm in Boston. I don't know if I do something with MIT, for example. Yeah, it will show me some of my pictures. It will show some pictures of MIT, but probably not the most relevant one. I mean, this is the most recognizable one. So search whatever you want. I will use something like, I guess like Boston skyline is good enough. There are like good pictures for this. So I will work with that. But first, create an account here on Flickr. And basically what you want to do, you want to go to and use something that is called the Flickr API, because these are the services, the API services that we need. Basically, we need to create like some sort of application, so we can have a secret number and like some sort of like token to access the database. If we only get like an account to search, it's not good enough, right? So we need to access the API, and the way to do that, we want to get an API key. So we go to flickr.com services API, and we go to API keys, and you see I have a couple of like keys and secrets. Actually, I should delete these ones because I'm not using them anymore. I will delete them later. But basically, the way when you have your access to the API, you can get a key, right? And I will delete this later, so no one uses this. So basically, you need to choose if you're doing like a commercial or non-commercial application. In this case, it's non-commercial, and let's call it like whatever. Analyze photos, like so it looks like it's like, I don't know, like a software. What are we building? A data, or basically like data set. A data set containing pictures for GAN training. You said like yes, yes, you put like a small description and then submit, and then you get like two numbers. So the first one is the key, and if we go to Visual Studio Code, the config Flickr.ini, we paste this, and then we just use the password. That is the secret, and we put our secret here. I'm sorry. So in this case, basically what you wanna do is put those things here. I don't remember if I need to put this as a string. Just let me check. Okay, so this is fine actually. You need to enter it like this. So you have like a couple of again, like other parameters. We look for example, like a path to download our images. Basically what we want to search, I said like Boston skyline, and we can put here skyline or something else that well, basically it's like a prefix. That's fine. Licenses, there's like basically what type of licenses do you want. So for example, here's like all right reserved, attribution on commercial. Basically here it asks you like what types of images with type of license do you want to get, and maximum downloads is 100,000 picture. It's a lot. And also the source of the files in case we need that. If you want to process your pictures, meaning that you need to format this in the same way, so you want to get like a minimum height and a minimum width. In this case, we're going to do it with 256 pixels, but we can go like larger than that because we're working with something that creates like high resolution images. We can go to, actually, let's go with 512. That's what we were using before. It would take, of course, longer to train. So, and what type of format do you want to use? We want images in JPEG. You can do PNG. That's fine. But basically, these are quite simple parameters. And the only thing that you need to do, actually, now, if you're not familiar with Visual Studio Code, you have the possibility of running or creating a terminal here. If you go to terminal, new terminal, this by default will create something. So let me do one thing. So this will give you something like this. So right now it is where I have this folder. It's giving me like the path in my address. But what I want you to do now after this is, in case you don't have it right now, most of you told me that you don't have experience. Let's do something. Let's download Anaconda. Something that I didn't tell you to download, I'm telling you now. If you Google Anaconda, the first link is Anaconda. This is the data science platform. It's this website. You go to get started, then download Anaconda installers, and then you select your operating system and what you want to download. In this case, I recommend if you're using Windows or Mac OS, or even if you are installing like Python, go for the 64-bit edition. In this case, I will download this. We will download this, and it's only like roughly like 400, 500 megabytes. So this will open the installer. This is really fast, nothing like scientific here. You said like, I agree. For who do you want to install this? Like all users in your computer, or just you, if you have like a special account? Where do you want to install this? And then this is important. Basically, you just click next, next, next. Don't do anything else. You just click next until it is installed. I already have it installed, so that's fine. It's not recommended that you add Anaconda 3 to your path or register Anaconda as your default Python 3.8 because it can create some issues. So after you install this, if you go to Anaconda, you will find something that is the Anaconda prompt, or if you're familiar with terminals or PowerShells, I will teach you how to do both. But in this case, I will just use something that is called the Anaconda Navigator. And the Anaconda Navigator basically is like an interface that allows you to create environments, virtual environments. What is this? So imagine that we want to work or install like a specific library in our computer, and sometimes, for example, you will find code that only works with Python 2, sorry, or you will find things that work with or things that work with Python or Python 3.5, but not 3.7. I don't know. Like there are some incompatibilities in some libraries. For example, if you want to use like some old TensorFlow 1.x version, you will find that those are not compatible with, for example, like, I don't know, Python 3. There are like all sorts of like incompatibilities between versions and stuff like that. If you learn how to navigate that world of like troubleshooting, like versions differences, you're okay. In this case, for example, we want to create environments because we can isolate those versions, those installations. So let's say I can have like 10 environments and different versions of PyTorch, or PyTorch with CUDA, PyTorch without CUDA, PyTorch with GPU, without GPU, and so on and so forth. One specific version of NumPy and the other one have also NumPy, but with another version. So basically it's to keep isolated the libraries and requirements, dependencies that you will install. So in this case, you will see something like this. If you don't have if you install Anaconda first instead of Visual Studio Code, actually you can install it from here, launch, and it will install a couple of things. I mean, you can install it. It's mostly for data science. So in this case, we go to environments, and you will see that I have like a lot of things here. A lot of different environments. I have ones for StyleGan2, Styles Transfer, like a lot of things that I don't even use anymore. So probably I need to clean some. But the good thing is that you can create a new environment here, and you can go to create. You need to give this an environment name. So in this case, it will be Digital Future GANs, DF GANs. And you can choose the flavor of, in this case, like what flavor of Python do you want to use? Like from 2.7 for older stuff, this is deprecated, this is not supported anymore. But sometimes you will find code that actually work with Python 2. I would recommend like doing 3.7 or 3.8. Let's go with 3.8 to see what happens. So I will create this environment, and this starts creating basically a folder with your username, your path to the Conda environments, and in this case, something that is called dfgans, and it's installing Python 3.8 and some dependencies as well, right? To basically leave everything like ready to start working in this environment. So we will do this because we need to install a couple of things, and it's a good exercise to actually go over this because we will use this in the next session. So in this case, this keeps asking me like to update. I don't want to update now. So here is dfgans, and if you click here, this play button, and if you go to, for example, like open terminal, you will see that this will open a terminal. In this case, it's like a shell Anaconda prompt, and the path, for example, to my user folder on Windows appears with a parenthesis before there's it's called like df underscore GANs. And this is because this is the environment activated. So for example, if I write like conda deactivate, I deactivate that. And to activate it again, I can say, for example, conda and list. So for example, if I have like many environments on my computer, I can just list all of them, conda env list. And I can see, oh, I have one that is like df GANs. So I can say like conda activate df GANs. And if I activate that, you see that now it appears. So it's showing me that it activated this. There are ways to create this on the terminal. I don't want to go through that, so I don't extend this. So this is working. That is fantastic. So we are fine. I'm going to close this. And I'm going to actually close Visual Studio Code as well. I'm going to open it again, because now when I open this, and it will open in the same folder than before. I want to, for example, if I select a Python file, you will see that here in the lower left corner of the screen, you see something that is like Python 3.9.264. So basically here you can find like in which like environment you want to start your terminal. So in this case, let me find the one that we just created. DF GANs. It's the name, right? So oh, so many stuff, so much stuff. DF GANs here. So if I select that, you see that now it's pointing that this is Python 3.8.10, 64 bits, DF GANs. And now if I start a new terminal, it starts a new terminal, and now it starts that terminal always pointing to that environment. So let's try one thing. Let's say, here, for example, I want to do Python Flickr download that PI. So I'm executing now this file, and we will get, of course, an error because we need to install a couple of things. So the first error here is in line 4 of this file that is telling us that we don't have, there is no module called Flickr API. So when you have something like this, you need to go here, for example, and you can say like pip, that is the Python package manager. You can say pip Flickr API. And here you see that if you go to py, you will find like what is the line of code that you need to basically use to install this dependency. So here in this case, if we go, I'm gonna clear the screen. If I say like pip install Flickr API, you will see that this will start collecting the packages and installing this Flickr API here. The good thing is that this will install the Flickr API only here in this environment. So if we want to install something else or a different version, it will do it, and you need to do it in another environment. So here, for example, it's telling us it cannot find, there is no module name PIL. PIL we use actually during the class. So for example, here I can say like pip PIL. And in this case, here we have pillow py. So also you can just press here and copy this command and pip install pillow and just paste it here. Paste it here, and you will install pillow. Easy and fast installation. Let's execute our Python code one more time. So now you see that this is working, and you see that this is actually just getting information. It's telling me the time, and it's starting the the process of collecting data. How do we know that it's actually working? We know that it's working because if we go to my G folder, data, and df, we see this populated with all of this squared, already processed Boston skyline pictures. So you see here that we have different pictures that were collected by Flickr images. This is not perfect. Sometimes you will see like some text, and you might want to like manually remove some. So for example, this was like super low resolution, so you can see that this was upscaled. Probably you will find, I don't know, like a picture of a dog or something like that that you might want to remove so it doesn't like interfere with the good quality of your data set. But we more or less we're getting decent pictures, I will say. Like these are, for example, this is an aerial picture of Boston, so we don't want this, so I can just delete it. You need to spend like at least a couple of minutes cleaning things that are undesired, let's say. So those are good. Yeah, in general, let's assume that we have like good enough pictures. So you see, this will update and we'll get like batches of images. We don't want to like basically create like too many requests on the API, so we don't get like any error. So for now, what I want you to do, if you do this, let it like downloading until you finish, and then I want you to upload this to your Google Drive, because we want to load this. And I will show you now actually how to perform the training. So let's move to that. I will start a new collab, as always. So in this case, just let me close a couple of things that I have here. So let me just open collab here. I will start a new notebook. I have my notes, but I will code it with you here. So the step one, again, you might want to verify if you're using like a GPU. So you want to configure this notebook settings, hardware accelerator. You want to use the GPU, and you might want to have like high RAM. But in this case, I'm just going to leave it here. If you see that this is crashing, just start again and use high RAM. Here, I'm going to put like step one or pre-step. Check GPU. Just out of sanity, I told you this in the morning as well. So underscore NVIDIA /SMI. So this will give you the information about what type of GPU are you using. So right now it's connecting to the allocating memory. So right now it says that we are using a P100. So basically it's not the fastest GPU. I mean, it's a very fast GPU, but not the fastest that they can provide. So we're using that GPU. And now as step one, we want to mount our Google Drive. So we will put here step one, mount Google Drive. And to mount Google Drive, we need just like code snippets. In this case, we can say like from google.collab import drive, and we can say like drive.mount, and we can give the mounting place like content /drive. This is the way that you mount your Google Drive here. And actually this needs to be quoted because this is a string. So if we do this and we execute this, it's giving me a error. Why is that? Non-point must be a directory that exists. So let me see that. It's like content. Oh, sorry, I had an extra point. Now it's mounting everything in content. So you need to go again. This is you select your Google account that you want to use. You copy this, then you go here and you paste that code that Google will give you. So after you do that, it will take you to the basically it will mount your Google Drive. It will take a little bit, but that is fine. And I will show you in a second how to upload your images. So after you mount your drive, you will see the folder here. So what I want to do is just go to actually my Google Drive. And from my Google Drive, I want to create a folder. I will create a new folder upload, and I can just select, for example, I know that it is still downloading data, but I will just upload this DF folder. So it's asking me to upload 1400 files. I will say yes. Probably it will start yelling at me. So I will do a couple of things. I need to erase a couple of things. So after you upload your files to your Google Drive, it's still uploading. It's only like 153 images. I mean, it has a long way to go, but you can see the folder here. So I can see that it is already like uploading some images. Those are like really high quality images, 512 by 512. So I want to close this because now I can keep with the coding of my code. So after we do that, to read the content, for example, we need to check also if we can access the file. So we can say like exclamation sign OS content drive, and in this case is my drive and df. So let's see if this actually lists the files that we have. So yeah, we see that we have information. This is showing, this instruction here is listing all of our files. So we know that we are golden, we will have our data. So now actually we go to the step 2, and the step 2 is pretty similar to what we did in the morning. So I will put it here, and I will say step 2 is clone StyleGan ADA to StyleGan2 ADA. Remember that ADA stands for like adaptive discriminator. So basically, it will do data augmentation as it's training or generating the training in the training process. Sorry. So we need to install this. So we will write the code. The code is git clone https colon github.com. I've done this so many times that I already know by memory. NV labs. I hope I don't get a typo. StyleGan2. It was StyleGan2 -ADA PyTorch .git. And also we will install, just as we did in the morning, pip install Ninja. So you see that we're doing here the same thing that we did for in Visual Studio Code to install a package or repository. So in this case, we're doing that. It's receiving the repository from NVIDIA. So I want to see if it actually worked. Yes. So you see here we have all the tools from the repository from NVIDIA. Now we want to actually create and format our data set. So the way that we will do that, we will put this as a step 3, create and format our data set. To do that, we want to do a couple of things. So for example, we can say, let's say we don't have an empty folder. So actually I want to create a folder. So in this case, I mean, it's good to have a folder. So I will create a folder here, new folder. Let's call it DF data set. And in case that we don't have that empty, we can say like rm minus r, and we can basically give that folder copy path to, in case we have something here in this folder, we just want to make sure that this will delete the content of that folder, so we can have something like clean in case we mess it up or things like that. So now what we want to do actually is to use a file that is called Python, and actually that file we can find it here. So we want to use the dataset tool. That is the dataset tool that we have here. So we can just copy the path, paste that here. We can specify as parameter, as an argument, the source, and the source will be the folder where we have our images. So our images is the directory called df. So I will copy that path. I will paste it here. So basically, this we're getting our images from here, and the destination, it will be actually the folder that we just cleaned here. The data set. So we just take like 3 parameter, and the parameters here is dest as for destination. So once we do that, we need to see if we finish. Yeah, we finish uploading our images. So we have 1,451 images. So that is good enough, I think, to get good results. So now we just press play. And it said that, yeah, there is no like such directory. Oh, actually that deletes the directory. So now we're creating it again. And you see that this is actually performing some like operations. This will create like, this will format our data set in a good way to actually perform our training. So this is almost our final stage. Basically now we are good to train something. So what we are going to do, we will go to step, in this case I lost count, step 1, step 2, this is step 3, and step 3 is the actual training. Is that easy? To train, we need to do a couple of things, like very simple things. So we need to import OS. Now we need to specify the path of the data set and the destination folder for the results, and modify. Basically, we need to format that. So to store the results, we can create a folder ourselves. So we can go to, for example, create a new folder. Let's create a new folder. df results. So we create df results, and we have that here. So we will copy that path, and we will say that results equals to this path. Now the data set location, we have that. So we can say like data equals to, and here we will go to the data set. So you see here we have a folder with 000. So basically here we will have like all our images that were transformed to JPEG, to PNG, and we will just copy the path and we will paste it here. So this will be the folder where the GAN will take the images. Now we will basically create snapshots. And for that, we will set a parameter that is called snaps, and we will set it to 10. And finally, basically, we just need to build the command that we want to run. And a good way to do this is just performing the following. So we need to build the command to start training. And we will say something like CMD, for example. We will create a string that it will be the user Python, user, how was this? User bin Python 3. Now we're gonna do, we need to point to where the training file is. This is a training file, so we will copy that path. We're going to paste it here. And now we need to, for example, say how many snaps are we going to reduce. So that is the parameter snap. And because we're using the curly brackets because we're forming a string. So here we can put the parameter snap, and now we can say our output directory is results. And finally, we need to specify where the data is, and the data is here. So with that, it's still creating our data set, but that is fine. We are going to write this code, and then we're going to write the last step. And before we start training, actually, I'm going to point you to one interesting thing in order to leave the computer on and just leave it as long as you can. So at least if you're using the free version, you will get up to 12 hours. And if Collab kicks you out, you can resume the training with the thing that I will point you next. But then if we want to run this command, so basically we just do this and CMD, and this will run. This command will start the training process. That is fantastic. So the final step, in case you want to keep training and you want to start from a checkpoint. So basically, like it's like a save file. The training, because you don't want to, for example, spend 2 days training something and then you get like a power outage, or by mistake you turn off your computer or close Collab Chrome, for example, or Chrome crashes. You don't want to lose that time, right? So basically, this will keep creating like save points, so you can you can resume your training from those save points. So in this case, we're going to do that because we see that we are 75% to finish this data here. So I will do like a final step. This is always optional in case you need more time, but this is step 4, resume training. So I mean, it will be like a I don't know, like good thing, for example, to just like train for 12 hours, then stop, then resume the next day 12 hours and things like that. So it's also like good because sometimes you can get like, I don't know, like some sort of errors or like undesired results. But I realized that the more time you train, the better the results are. But you never know. I don't know. Maybe you see that after 8 hours you're getting good enough results. So that will be fantastic. So to resume the training, we're going to do import OS, and now we're gonna we are going to copy the same things, right? We're going to copy results, but the only difference is that we're going to say like network, and that network will point to like a snapshot file. So for example, I mean, I cannot show you with an example because we didn't start the training, but basically this will be the path to your PKL file. So this will produce in results like several things, but it will produce like a bunch of PKL files. Like those will be those save files. And because you're also producing images from those PKL files, you can match the pickle file with the images that it's producing. So you can say like, I'm gonna resume, I don't know, like training from the second file or the file number 10, not the last one. So you have the option. So you need to change the path to this file. Also, for example, someone mentioned during the class that what happens if you always start from noise. You can actually, if you're using like, you can start from another PKL file, like pickle file. So that is completely fine. I think it won't give you an error. And the data set, you need to, again, specify the data. And finally, you want to also create the snapshot, so you need to copy and paste. And the command, it will be, you need to rebuild the command, and we'll select CMD, and it will be like pretty similar. CMD, we want to create a string, format a string. So we'll write F, and we will do pretty much the same thing. We will copy this. We're going to be lazy. So copy the path to the train file. And now we can copy, actually we can copy like pretty much the same. So let me copy everything. Let me just paste it here. We just need to add one modification, and that modification is here. We will say resume and open curly brackets, and here we will say resume. That is something that I didn't put, so I need to put resume, and resume will be here, resume. This will be resume, and we will do like OS, that path, that join. We will start from results, and here we will here basically this is something that I need to show you. How can I do it if I don't have anything trained here? So let me network. So basically this, the resume needs to point to a PKL file name. So maybe I can show you a couple of things here. I think I have a model train at some point, like FG. Let me see, probably not. This is a data set with images of Frank Gehry that we used before. Probably here. Yes, so here I have a folder with results, for example, Frank Gehry, and you will see that the folders will have like this format, right? So in this case, you will have like something that is like, you see, it creates like a bunch of images. It will also like some fakes. So you will see this type of things being generated. So this is one of the images generated at some point of the training with Frank Gehry images. You will find, you see the snapshots. These are the things that you're creating, like how many snapshots do you want to create? But basically what you want to point to with this string here is to the name of this folder. So basically for example, if your folder, you want to resume from this folder, you will write, these are 500000 dash auto 1, and that basically will take this it will resume from this point to actually resume the training. So let's assume that everything works fine or was written fine, so we can start our training. But before that, just one more thing. Just let me get, because it's a trick that is actually quite useful. I don't care like opening that image. Just give me a second. We'll go. Let me find my notes. So we need to, I'm going to put it here, a trick so you don't get disconnected from collab. And that trick is the following. Actually, I don't need to put it as a code. I'm going to delete this. I will put it like this, because this will be formatted as code. And you just need, I have it, of course, somewhere in a TXT file in my computer. Let me find it. I need to find it in my notes. Almost there. We're almost there. Here it is. This is basically just a JavaScript function. And that JavaScript function is this. Actually, I need to delete this guy here. and actually I can delete this. So this is a code. Basically, it's a JavaScript function, and you just need to copy this. You copy this code, and then you do the following thing. You go here on Chrome, and then you go to More Tools, Developer Tools, or Control-Shift and I, and you will see that this will open the JavaScript window. You can basically clear the console, and the only thing that you need to do is copy this code, paste it here, and this will simulate clicking here, right? Or clicking at like some point, like I don't remember where. Like basically, it's like it will do a query selector, tube toolbar, collab connect button. Yeah. So basically, it will click here, and you will see that this will happen all the time while you're training, because it will simulate that. It will automate that clicking in an interval that is good enough to keep collab running. So once you paste this here, you just press enter. So you will see after a while that this will, I'm not clicking, you see my hands are like completely free, and you will see that this actually will click on this. So we executed everything. We created our data set. Let's check one more time our data set. DF data set. This is our data set, you see here. And now that we have our data set, we can just start training. So hopefully we don't have any typos. Apparently we don't. So this is just starting. So if you see this, basically you will start training this started the process of training. And because this is already working, you will see a message, and you will see this like just clicking itself, and you see I didn't touch it and it just clicked. So you will see this loading is pretty similar to what we had. Here is telling us that the image shape is a 3 by 500 512 by 112 images of like the side pixels, sorry, and 3 channels RGB. And this will start. This is starting. So it's quite amazing, because now this, you see here that it says that it's setting up the augmentation, it's distributing all the data across the memory of our GPU, and exporting sample images, and it will start training. So hopefully, if you follow this tutorial, I will give you the code, and you will have this after, usually I leave it for like, I don't know, like 20 hours, and I get like good results. So I can see also like what results I'm getting. So play with this over the weekend. If you don't want to use the Flickr tool, you just use your own tools. That is fine. You can see in the video the directions where to get all the files. Try to code it yourself. I will upload this. I will put it in the description of the video, all the data to do the training. Actually, I will change the name here. So this is training StyleGan2 ADA. And again, if you want to get really into this, use Linux. And also, if you're interested in training because you want to do a paper or any work that is meaningful, and you need to get like good training, you have 2 alternatives. Runway ML that trains very well and fast, or you can do it here and have like 12 hours of training, or pay $9.99. That is actually quite cheap to use like a lot of GPU power. It's actually way cheaper than buying a GPU nowadays, when you can, for a good GPU, you pay $3,000. So that is crazy and insane, and I'm never going to do that. So this is, you see that this is training. This is all good. So let me know if you have any questions. If you are watching this video on YouTube, I acknowledge that most of the code was like scattered from different parts over the internet, and the Flickr code is from Jeff Heaton. He has a very nice YouTube channel with things related to machine learning and other stuff. So thank you very much, and I hope, and I will show you how to use this information or data or stuff in Grasshopper. So See you.